In this particular chapter, we consider these two translators, that is, one is the compiler and another one is the interpreter. Compiler, it is one of the translators who translates the high level language into the low level language. Now this is the statement which is all of you are familiar with this particular. Now in this compiler, that is, this compiler is used for every programming language to compile that particular language into the corresponding low level language. That is, our high level language is not understandable language to the computer directly, so we need to convert, or the program needs to convert into the machine language, that is in the form of 0 1. For that purpose, that translator is required. We call that translator as a compiler, that is, which helps you transform the source code written in high level language to the low level language. That low level language is nothing but our machine language. Okay, now we translate the code written in one programming language to some other language without changing the meaning of the code. This is the most important statement about this compiler. Those statements written in the high level language, we write that statement according to our meaning, according to our logic. Okay, that logic should not be changed when that program is translated with the help of this compiler. That is the most important task is performed by this compiler. Now in this case, that is, compiler also makes the end code efficient, which is optimized for execution time and memory space. Here total program at a time, we pass a whole program to the compiler. Compiler can convert whole program at a time into the machine language. Okay, and that machine language program is executed with the help of execution, or with the help of that loader and other system programs. Now in this case, what happens, that is, our execution time will be improved, and the memory space is also improved, because we require to store complete optimized code. We store the complete object code into the memory. There is no need to store large amount, or no memory, large amount of memory is required to store that particular program. Here binary code requires least space than that our high level language representation. आपण जेव्हा हाय लेवल लँग्वेज मध्ये प्रोग्राम कन्सिडर करतो, त्यावेळेस त्याची जी मेमरी रिक्वायरमेंट असते ती बायनरी लँग्वेज पेक्षा जास्त असते. आणि जेव्हा तुमचा कोड हा ऑप्टिमाइज फॉर्मॅट मध्ये घेतला जातो, आणि ऑप्टिमाइज फॉर्मॅट मध्ये कोड जेव्हा तो मशीन लँग्वेज मध्ये कन्वर्ट होतो, त्यावेळेस त्या कोडची साईज काय झालेली असते, रिड्यूस झालेली असते. आणि इट ऑल्सो improve the execution time of that particular program. In this, the compiling process includes the basic translation mechanism and error detection. That is, what type of errors are occur in your program, that is the semantic error, syntax error, or any other type of error that should be identified during the compilation process. Now this compilation process used to handle all these things, used to handle all these particular representation corresponding to that of the program. Now you know very well, when we compile the C program, or when we compile the C++ program, we will get some errors. Now first of all, we need to remove that error, and then we need to again compile that. Till our 100% errors are not removed from the program, then till that particular program does not executed. जोपर्यंत तुम्ही सगळ्या एरर्स प्रोग्राम मधून रिमूव्ह करत नाही, तोपर्यंत तुमचा ऑब्जेक्ट कोड किंवा जो कंपाइल कोड असेल, तो कंपाइल कोड त्या ठिकाणी क्रिएट होत नाही. आफ्टर कंप्लीटिंग, और आफ्टर सक्सेसफुल compilation, our object code is also is generated with the help of this particular compiler. That is, the compiler process goes through the lexical syntax, semantic analysis, that are the front end, and the code generation and optimization at the back end. That is, here we can consider total 7 number of phases. In that case, some phases were combined into the code generation, and some during this optimization. That is, here we consider only 5 phases, that is the lexical analysis, syntax analysis, semantic analysis. These 3 phases should be considered as the analysis phase, as the front end phases. Okay, and remaining 2, that is, here we can consider the code generation phase and optimization phase, that is nothing but the backend phase. These are does not related to that of the user representation. Okay, now here we can see this particular representation of a compiler high level language given to the compiler. Compilation errors were generated, given to the user correct them, and again program will be compiled, and we get the output of that compiler as a high level language. Now in this case, this what are these particular phases, what tasks should be handled with that particular phases, that is using the lexical syntax or semantics, or front that is the code generation and optimization. Here lexical analyzer is nothing but the scanner in the sense that is the complete program will be scanned, and that particular tokens will be generated with the help of this lexical analysis phase, or during the lexical analysis. Now those tokens were generated with the help of this lexical analysis phase given to that of the syntax analysis to check the syntax of the given tokens or a given statements. Okay. Now after checking the syntax, if programmatically the given syntax were correct, then it is given to the semantic analysis. Semantic analysis, that is to know the meaning of that particular statement. In this identification or meaning identification phase, compiler needs to know the programming language, which language belongs to that particular statement. This is most important for the compiler or identified by the programmer. Then and then the meaning of the given sentence will be identified. Now what happens, that is, if we consider the C programming language compiler, that is we consider Turbo C or GCC compiler in case of the Linux, then that compiler know the meaning of a statement or a syntax of the given C language statements. That's why it identify the meaning of the given statement easily. Okay, that's why first of all we need, or that compiler requires the language identification, then and then the meaning should be identified. Now these three phases are done at the front end of the compiler, that is creation of the tokens, checking the syntax and identifying the meaning. After identifying the meaning, then intermediate code representation will be generated. That is, we will discuss that intermediate code representation in the assembly language. Okay. Now, after identifying this, after completing semantic analysis, that intermediate code is generated. Now, here we consider this code generation phase under that particular intermediate code generation. Okay. Now, that intermediate code generation phase, then next after that we that compiler or we pass the particular code to the assembler or a macro preprocessor or macro assembler. Okay. Now, assembler will perform some rearrangement of that particular statements. That is, assembler task is nothing but converting that particular assembly statement in the form of the machine language, that is in the form of the target language. Okay. Now this code optimization phase belongs to that of, that is, it optimize the code. Now some of the statements which are repeated, okay, some of the statements are common, they require the execution only once. Okay. Now some here code optimization phase is nothing but to reduce the size of a program, to reduce the size of a code without changing the meaning of the given code. Now it contains some other subtypes of some other phases also. That is, when we consider the code optimization, during the code optimization, frequency reduction can take place. Then strength reduction of a code can take place. Then a common sub expression can be eliminated. Like this, all these phases will be executed during that particular code optimization. Okay. Now in this case, some of the statements which executed once and can occur multiple times, same expression can occur multiple times. Now that particular statement can be executed at once and the result will be stored at a temporary variable, and that temporary variable is used again and again. That is, it reduces the some execution, repeated execution of that particular statement. That is nothing but the code optimization. After completing the code optimization, our code size is reduced to 40%. Okay. जी कोड साइज असते प्रोग्रामची साइज जी असेल ती 40% रिड्यूस होते, and it execute or the time of execution of a program which increases to the 25% because rearrangement of the statements is required at the time of program execution. That's why 25% memory or 25% time will be increased for the execution of that particular code. That is nothing but the compilation process or all the phases which requires for to perform the compilation of a program. Every time when we compile the program, all these phases will be handled corresponding to that program. एकदा तुम्ही एक प्रोग्राम एका वेळेस कंपाइल करत असताना त्यामध्ये ह्या सातही फेजेस काय होतात ऍट अ टाइम त्या ठिकाणी एक्झिक्यूट होत असतात. नाउ ड्युरिंग द लेक्सिकल एनालिसिस, ड्युरिंग द टोकन जनरेशन, इफ देयर इज एनी एरर विल बी ऑकर्ड, देन इट इज identified or returned to the user correctly. If error is identified during the syntax analysis, then that error is returned to that of the user correct it, and again compilation will be takes place. If language semantic or during this semantic analysis error will be generated, then it is also given to the user. Now all the errors are removed at this particular three phase, that is at the front end of the compilation process. Okay. Now all the errors are removed, and then final program will be compiled, or the complete program will compile, and it generates the low level language. That is nothing but the compiler in our programming language. Every programming language has such a type of compilers, that is the translators. They translate the high level language into the low level language. Okay. Now, next thing here we consider one more translator, that is nothing but the interpreter. This is the main part of this particular chapter. Now, in this case, the task of compiler and interpreter are similar, but here some of the differences can be given in during this particular translation. Now, in case of the interpreter, that is the computer program. Okay, it is also one of the computer program. Now, it is used to directly execute the program. Okay, directly execute the program instruction written using one of the many high level programming languages. कुठल्याही प्रोग्रामिंग लँग्वेज मध्ये तुम्ही राईट केलेलं स्टेटमेंट, नाव दॅट interpreter execute that particular instruction. Now here I can say the instruction, we focus on the particular instruction, that is interpreter translate a single instruction into the machine language, execute it, and then consider the next instruction or get the next instruction. That is the working principle can be considered in this particular figure. Now we can see this source code given to the interpreter, executable code will be generated, and that code should be executed. After completing the instruction execution of code execution, it get the next instruction, that is a single instruction from the source code. Again it passed to the interpreter, interpreter execute it. Now this circle continue till the program is completed. Okay, म्हणजे तुम्हाला एका वेळेस एकच इन्स्ट्रक्शन काय करता येते, त्या इंटरप्रिटर थ्रू त्या ठिकाणी ट्रान्सलेट करता येते आणि तिला एक्झिक्युशन त्या ठिकाणी त्याचं कम्प्लीट करता येतं. Now interpreter transform the high level program into the intermediate language that it then executes, or it could parse the high level source code and then perform the command directly, which is done line by line or statement by statement. Now you can see that is a line by line or statement by statement. That is, translation will take place statement by statement. While we consider the compiler, whole program can be translated at a time in the form of machine language. ओके, कंपायलर मध्ये पूर्ण प्रोग्राम एकाच वेळी ट्रान्सलेट होतो, इंटरप्रिटर मध्ये तुम्हाला एक एक लाईन काय करावी लागते त्या ठिकाणी ट्रान्सलेट करावी लागते. Now interpreter reads each statement of a code and then convert or execute it directly. Now since the interpreter reads and then execute the code in single process, it very useful for scripting and other small programs. That is, when we consider the little bit programs for the execution, we need to trace that particular programs. We want to check the output of every statement of the program. At that time we can consider this interpreter. Now in other words, we can say this program or these interpreters are used by who start for the programming. ज्यांनी प्रोग्रामिंग स्टार्ट केलं किंवा ज्यांना नवीन प्रोग्रामर्स असतील अशा लोकांसाठी तो डिबगिंग ऑपरेशन परफॉर्म करण्यासाठी ह्या इंटरप्रिटरचा काय केला जातो त्या ठिकाणी यूज केला जातो. नाउ एव्हरी सोर्स स्टेटमेंट विल बी एक्झिक्युटेड लाईन बाय लाईन ड्युरिंग द एक्झिक्युशन, which is particularly appreciated for the debugging reasons to immediately recognize the corresponding error. Now every statement is translated. If any error is occurred during that particular statement, single statement, then that error should return to the user. म्हणजे आपण प्रत्येक लाईन वरती जर एरर आयडेंटिफाय करत जातो, प्रत्येक लाईन मध्ये एरर त्या ठिकाणी चेक होत जाते. जसं कंपायलर मध्ये जेवढा प्रोग्राम कंपाईल होतोय, कम्प्लीट प्रोग्राम त्या ठिकाणी स्कॅन झालेला असतो, त्या कम्प्लीट प्रोग्राम मधनं सगळ्याच्या सगळ्या एरर ऍट अ टाइम तुम्हाला काय केलं जातात, रिटर्न केल्या जातात. इथे एकाच स्टेटमेंट मध्ये ज्या एरर आलेल्या असतील त्या एरर काय होतील तुम्हाला शो केल्या जातील. Now it is also used for the educational purpose, since they can be used to show the student how to program on one script at a time. तुम्हाला तो एक स्क्रिप्ट एका वेळेस कशा पद्धतीने रन होते किंवा प्रोग्राम कशा पद्धतीने डिबग होतोय, आउटपुट कशा पद्धतीने त्या ठिकाणी प्रिपेअर होत जाते ते आयडेंटिफाय करण्यासाठी हे इंटरप्रिटर त्या ठिकाणी आता मी सुरुवातीला सांगितलं की इट इज व्हेरी युजफुल फॉर द बिगिनर्स ऑफ अ प्रोग्राम. ओके, प्रोग्रामिंग साठी जे बिगिनर्स आहेत, नवीन आहेत, अशा लोकांना हे इंटरप्रिटर्स काय करता येतात, यूज करता येतात. Now such interpreters are used on a small set of a programs, that is it requires or it is feasible for the small programs. If you consider large program or very large systems, then interpreter is not feasible for that particular location. Okay, that is nothing but the interpreter. Now here use of the interpreter, why we can use here, we can consider there are two reasons to use the interpreter. First one is efficiency in a certain environment, and second thing is nothing but the simplicity. Interpreter is can be considered in certain environment, in the sense that is we can consider the small programs. In that small program we can consider the interpreter. There is no necessary for the compiler. Okay, now that is at that particular location it is very efficient. That's why we can use that interpreter, or the reason behind to that using the interpreter. And simplicity, that is interpreter designing is very simple because we require single statement translation. Okay, that is the simplicity. These two reasons we can use the interpreter. Now for the efficiency, you can consider this particular example given in your book. That is, here we can see a program P. Okay, in that particular program P, we can have some statements regarding to that of the program P. That is, we can consider size is yes, which represents number of statements. Here size is given to that particular program. Then number of statements in the program, that is the yes, and number of statements executed in some execution of a P in N. N is nothing but the time required to execute that number of statements. Now, how that interpreter is efficient in that particular environment, that example will be shown. That is, to compute the CPU time required to execute the program using compilation or interpretation. Now we can assume some parameters, that is TC, which is considered as the average compilation time per statement. Then TE, which is considered as average execution time per statement. Okay, this is the compilation time. TC in the sense compilation time. TE is nothing but execution time, and TI, it is the average interpretation time per statement. Okay, compilationचा पण टाइम घेतलाय आपण त्या ठिकाणी आणि इंटरप्रिटेशनचा पण टाइम त्या ठिकाणी कन्सिडर केलाय. Now here what happened, that is here TE, that is average execution time, is less than compilation time. That is, average execution time of a compiler is much smaller than compilation because executable code is in intermediate form. Okay, here we can consider TC equal to 20 TE into bracket 20 times TE. Okay, TE जो compilation time जो आहे तो कशाचा इक्वल आहे, एक्झिक्युशनच्या 20 times multiple equal to that particular compilation time. Okay, now here yes should be considered as 200. That is, yes is nothing but the statements, number of statements in the given program. That size should be considered as a 20. Let program P execute as follows. How that program is executed, we can see 10 statements are executed for initialization process purposes. Okay, 10 statement त्यामधले initialization साठी वापरले गेले, and this is followed by the 10 iterations of a loop containing a statement. 10 iterations आहेत, प्रत्येकामध्ये किती स्टेटमेंट आले, एका इटरेशन मध्ये 8 स्टेटमेंट आले, म्हणजे 8 गुणिले 10 असे टोटल किती झाले तुमचे 80 स्टेटमेंट इटरेशन्स मधले झाले. नाउ फॉलोड बाय द 10 स्टेटमेंट फॉर प्रिंटिंग द रिझल्ट. 10 स्टेटमेंट रिझल्ट प्रिंट करण्यासाठी वापरले गेले. नाउ हियर वी कॅन कन्सिडर द नंबर ऑफ स्टेटमेंट एक्झिक्युटेड. किती स्टेटमेंट एक्झिक्यूट झाले इथे 10 प्लस 10 इनिशियलायझेशनचे स्टेटमेंट एक्झिक्यूट झाले, 80 इटरेशनचे स्टेटमेंट जे ज्या ठिकाणी आपण लूप कन्सिडर करतो ते लूप स्टेटमेंट 80 एक्झिक्यूट झाले, आणि राहिलेले 10 स्टेटमेंट रिझल्ट प्रिंटिंग साठी एक्झिक्यूट झाले. टोटल स्टेटमेंट्स वेर एक्झिक्युटेड इन दिस पर्टिक्युलर प्रोग्राम इज नथिंग बट 100. ओके, दिस इज द प्रोग्राम एक्झिक्युशन नंबर ऑफ स्टेटमेंट. आपण प्रोग्राम साइज किती कन्सिडर केली 200, एक्झिक्यूट किती झाले त्यामधलं 100. नाउ दस टोटल एक्झिक्युशन टाइम युजिंग द कंपायलेशन. कंपायलेशनचा यूज करून जर आपण एक्झिक्युशन टाइम कॅल्क्युलेट केला तर तो या ठिकाणी कशा पद्धतीने मिळतोय बघा, 200 इंटू TC कंपायलेशन टाइम कन्सिडर केला इंटू प्लस 100 इंटू TE. एक्झिक्युशन किती झालंय 100 स्टेटमेंटचं एक्झिक्युशन झालंय. ओके, म्हणजे त्या ठिकाणी TE ने काय केलं 100 ला मल्टिप्लाय केलं. TE, we consider that TE as a average execution time per statement, which is multiplied to that of the 100. And here we can consider 200, that is, we can say compilation can take place total program. कंपायलेशन कोणाचं होतं, पूर्ण प्रोग्रामचं कंपायलेशन होतं, म्हणजे 200 स्टेटमेंट आहे, 200 चे 200 स्टेटमेंट त्या ठिकाणी कंपाईल होतं. हियर वी कॅन कन्सिडर कंपायलेशन टाइम प्लस एक्झिक्युशन टाइम. हियर वी कॅन से 200 into TC, 200 TC plus 100 into TC upon 20. We can calculate this particular time in the form of compilation. Okay, then we will get approximately 205 into TC. एवढा टाइम काय झाला त्या ठिकाणी कंपायलेशन साठी रिक्वायर्ड आहे. नाउ द टोटल एक्झिक्युशन टाइम युजिंग इंटरप्रिटर. इंटरप्रिटरचा यूज करून एक्झिक्युशन टाइम किती आहे, हियर वी कॅन कन्सिडर 100 into TI. ओके, आपण इंटरप्रिट एक्झिक्युशन डायरेक्टली करतोय, म्हणजे आपण इंटरप्रिटर थोडक्यात या ठिकाणी वापरतो. मग जेवढे स्टेटमेंट एक्झिक्यूट होणार आहे तेवढे स्टेटमेंट त्या ठिकाणी इंटरप्रिट होणार आहे किंवा तेवढेच कंपाईल होणार आहे. 100 स्टेटमेंट एक्झिक्यूट होतात, म्हणजे तुम्हाला किती स्टेटमेंट एक्झिक्यूट करायचे, फक्त कंपाईल करायचे त्या ठिकाणी 100 स्टेटमेंट फक्त कंपाईल करायचे. नाउ दिस इज द कंपायलेशन टाइम of a complete program with the help of compiler, and this is the interpreter time which is implemented with the help of interpreter. Okay, now we can see in very easily this is the time maximum for the compilation and execution, and this is the less time for with the help of interpreter, because only request statement were executed. Now therefore the interpreter is beneficial in this particular situation. Okay, now during the program development, if number of executable statements are less than the size of a program, एक्झिक्युटेबल स्टेटमेंटची संख्या जर आपल्याला प्रोग्राम साईज पेक्षा कमी मिळत असेल तर आपण त्या ठिकाणी इंटरप्रिटर यूज केलेलं योग्य असणार आहे. दॅट इज इंटरप्रिटर इज प्रेफर्ड. Okay, now since interpreter does not involve code generation, that is debugging is very easy with the help of this particular interpreter. आता ज्या ठिकाणी आपण जेवढ्या लाईनचा प्रोग्राम घेतला सगळ्याच्या सगळ्या लाईन जिथे एक्झिक्यूट होणार आहेत त्या ठिकाणी दोघांचाही परफॉर्मन्स काय असेल, तुमचा कंपायलर एज वेल एज इंटरप्रिटर इज सेम. But where we can have large number or we have n number of program statement, but we required among n number of statements we required only some statements, that is suppose n minus I statement will be executed, I will be considered as any imaginary number. मग त्या ठिकाणी काय करणार तुम्ही, इंटरप्रिटरचा यूज करणार. दॅट इज n is less than yes, then we can consider the interpretation. Okay, that is all about the interpreter, and where we consider the performance or where we consider the environment. Here we represent this particular program with corresponding to the environment also and corresponding to that of the particular efficiency also. Here if interpreter is more efficient than that of the compiler. Now this value is put from with the help of this particular TC equal to 20 times TE. Okay, this value for the TE will be considered. TE ची व्हॅल्यू कॅल्क्युलेट करताना TC डिवाइडेड बाय 20, हे 20 काय होतील इकडे येतील. त्या पद्धतीने हे TC कन्सिडर केलंय आणि नंतर त्यांची ऍडिशन तुम्हाला जी मिळते किंवा हे एक्सप्रेशन इव्हॅल्युएट झाल्यानंतर तुम्हाला हा टाइम त्या ठिकाणी मिळतोय. दॅट इज ऑल अबाउट दी इंटरप्रिटर रिप्रेझेंटेशन. नाउ वेअर इंटरप्रिटर इज यूज्ड, कुठे तुम्हाला वापरायचं आहे. नाउ हिअर ड्युरिंग द प्रोग्राम डेव्हलपमेंट यूजर टिपिकली डिबगिंग अँड टेस्टिंग द प्रोग्राम, that is running the program on unknown data to evaluate its corrections. Okay, now second thing is editing the program to remove the logical errors. At that time we can consider the interpreter. Okay, that is during the program development. Then second one, that is in environment where only one execution is typically desired, that is a database command typically interpreted. Okay, or an operating system command is typically interpreted. जर तुम्हाला डेटाबेसची कमांड एक्झिक्यूट करायची असेल तर इंटरप्रेटर वापरला जाईल, किंवा ऑपरेटिंग सिस्टीमच्या कमांड एक्झिक्यूट करायचे असतील, सिंगल स्टेटमेंट आहे, पूर्ण कमांड कंपाइल करण्याची गरज नाही, ओनली दॅट सिंगल स्टेटमेंट विल बी एक्झिक्युटेड इन विच वी कॅन कन्सिडर द कमांड, we can use that particular interpreter. That is the environment where only one execution is required. And third use is nothing but in environment where dynamic program modification is an advantage. Okay, all these three are the use of interpreters. Now we can consider all these things under that interpreter. Now next point will be considered or discussed, that is the advantages and disadvantages of the interpreter. Now that point we will consider in the next lecture. Now today's lecture we can conclude at this particular point. Okay, now we can stop the lecture now.